In this video, we'll be talking about quadratics on the ACT. Before we get there, just some reminders about what quadratics were from the previous year in Algebra 2. Quadratics are functions of the form ax squared plus bx plus c, also called standard form, or f of x equals a times x minus h squared plus k, which is called vertex form. Okay. As a reminder, a function is always going to be something that passes the vertical line test. Okay, so on an ACT, when you're given a group of graphs and you're asked to find which one is a function, you just take your pencil, place it vertically, and just drag it across the graph. If the graph only ever hits 1 point, then it's a function. If it hits more than 2 points, or more than 1 point, then it is not a function. Okay, so just quick reminder on that. All right, on the ACT for quadratics, we'll be focusing on these two equations. Okay, there's also one more formula that we'll need to know, and we'll get to that once we cross that bridge. But these two equations and knowing what each of these letters does is super important. So there are different types of questions about quadratics on the ACT. Okay, how would you factor blank? So it'll give you a quadratic equation, and you have to factor it. Okay, what are the zeros of this equation, or where it crosses the x-axis? What is the highest or lowest point, or find the vertex? And what graph matches the equation, or what equation matches the graph? Okay, so there are kind of 4 different types of questions: finding zeros, finding the factors, interpreting a graph, and finding the minimum or maximum. So let's start with factoring. All right, and we covered this on our last session, but I wanted to quickly do it one more time. So what are the factors of the given equation? All right, so in this first example, what are the factors of f of x is equal to x squared minus x minus 6? All right, I'm going to put, since it's x squared and x, I'm going to put 1s in front just so we know what the coefficients are. And then that last constant is negative 6. So when you're given an equation like this, where the front coefficient is 1, you're going to ask yourself, what factors of this constant add up to this coefficient? Okay, and really, this coefficient is negative, and this constant is negative. Okay, so we need factors of negative 6 that add up to negative 1. So factors that do that, if we just kind of list a couple of factors, negative 3 and positive 2, those add up to negative 1. Okay, so negative 3 and positive 2 will be our factors. All right, so this will factor as x minus 3 times x plus 2. And obviously there are multiple choices. This would be the one you choose. Now, you can also work from the answer to the equation. So if you are a little bit unfamiliar with factoring, I would start from A, B, C, D up to this original question. That might take a little bit of time, so that might be something you come back and do. But it's something that is viable so long as you have a little spare time, or can FOIL really well. Okay. The other type is the same question, except our coefficients are bigger up front, right? So instead of 1 in this position, it's 3. It's still kind of the same question, though. We need factors of negative 10, where when 1 is multiplied by this 3, we get positive 13. Now, I do this a little bit differently. I do this area method, which again, I kind of went over in the last session, but I want to go over one more time. Okay. In the top left box, 3x squared, and in the bottom right box goes negative 10. And basically we're trying to find the lengths of these smaller boxes in order, or such that the area is the inside. Okay, so what times what is 3x squared? All right, so it'd be 3x times x. And then we need factors of negative 10 that go here and here, where when 1 is multiplied by this top 3, we can add these two areas up and get this middle term. So it's a little bit complicated. Again, you can work from the answers and go up, but if you're really good at this factoring stuff, it can sometimes be a little bit faster. Okay, so in order to get so factors of 10 that in some way add up to positive 13, I'm going to try positive 5 and negative 2. So I'm going to try positive 5 here and negative 2 up here. Right, so positive 5 times negative 2, that's negative 10. So that checks out. Positive 5 times 3x, that's 15x. X times negative 2, that's negative 2x. And then these two boxes add up to positive 13, so our factors check out. Again, this can be a little bit complicated. You can factor it the same way we did in this first one, except there's one more thing to take into account. Again, this is just the way I do it. Okay, so then our final factors are 3x minus 2 and x plus 5. Now, a similar type of question that requires kind of one more step is what you see up in red. So for all x squared plus 6x minus 27 over x plus 9, basically what does that equal, or how do you simplify that entire thing? Okay, so in order to simplify this, usually it requires factoring. So we would have to factor this top part and then simplify, so cancel out common factors with the numerator and the denominator. Okay, so if we factored x squared plus 6x minus 27, we need factors of negative 27 that add up to positive 6. And two factors that do that are positive 9 and negative 3. All right, so then our factors would be x plus 9 times x minus 3. And then this denominator stays where it was. Then you look at the numerator, you look at the denominator, and see what is the same. Okay, so in this now factored problem, right, we can cancel out common factors. So x plus 9 is common in the numerator and the denominator, so then our final answer is just x minus 3. So next, we need to find zeros. Okay, there are two different, well, there are a lot of different ways of finding zeros. Okay, you can factor it and set the factors equal to 0. You can use the quadratic formula, or you can use your calculator. Okay, I'm going to show you how to use the quadratic formula. We just did factoring, so let's focus on that quadratic formula. All right. For those who don't remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And the couple of practice problems that I found about this were to simply plug in a, b, and c, and then you would have your answer. Okay, which is really, really easy. Keep in mind, a is always the front, b is always the middle, and then c is always the constant. All right, so if we just plug those numbers in, we would get negative 13 plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so for the couple of problems that I found, just this would get you the answer. Now, if it is a simplified version, we would probably simplify just a little bit and get a couple of answers, and then it would be done. Okay. If you do decide to type this into a calculator, I would make sure that the parentheses are as I have written, and then just type it out exactly as is. So if we simplify that just a little bit, so as of the first 10 or so questions that I found like this is the answer. Sometimes they decide to go a step further. So if we do that, we get negative 13 plus or minus 13 squared is 169 minus 120 all over 6, which is equal to negative 13 plus or minus the square root of 49 divided by 6. And we can go one more step. So the 49, square root of 49 is 7. Negative 13 plus 7, that's negative 6. Negative 13 minus 7, that's negative 20. Right, so we have two answers with the plus or minus. Negative 6 over 6, it's just negative 1. Negative 20 over 6 would be negative 10 over 3. And then those are our answers. So then we have finding vertices, all right, which will be called the lowest or highest point of the graph. So a question that'll be asked, what is the lowest point of the following? Okay. When you see this, these equations are in the form a times x minus h squared plus k. Okay. And the vertex of any equation in this form is always going to be hk. So really all you have to do is pull out two numbers, maybe interpret it just a little bit, and then that's it. Okay, so for this first equation, right, we take the negative of what's inside. So we take the opposite of negative 3. That's our h. And then the exact same of what's on the outside. So that's just positive 2. So our lowest point of that graph is 3, 2. On this second equation, it's the same thing. Okay, in this case, it would be what is the highest point, because this is negative. And we just pull out the same two numbers. So we pull the opposite of what's inside. So this would be negative 2. And then exactly what's outside, so negative 4. So negative 2, negative 4 is our answer. And then lastly, we have matching graphs with equations and equations with graphs. All right. So obviously this will be a little bit easier with different options, but I want to take it without them, just so we know how to do these types of questions. All right. So on this first type, we want to match the graph with the equation. All right. So say we're given this graph, and we see that our vertex is right at this point, which happens to be 5, comma 3. Right? 5 is the x value, 3 is the y value. Because we have that vertex, we can actually get most of the equation. Okay? So because we have this vertex and we have the direction of the graph, we have most of our equation. All right? So if we just start writing, we have f of x is equal to some negative number times x minus 5. Right? It's the opposite of that x value. And then plus 3. And that's all there is, right? So we need to know that because this parabola is opening downward, that this a value will always be negative. And then because our vertex is at 5, 3, we know that there's going to be a negative 5 inside and a positive 3 outside. Okay, for the second problem, we would want to match this equation with the graph. Okay, so if we just start drawing a graph, the first thing we should get is the vertex. Right, and the vertex will be the opposite of what's inside, so negative 2, and then exactly what's outside, so positive 3. So the first thing we would do, plot our point, negative 2, positive 3. And then from there, the last thing we need is the sign of this number right here. And because that's positive, it will open up, and that'll be our graph. So to recap, there's a couple different types of questions about quadratics. Okay, there's finding zeros, there's factoring, there's matching graphs with equations, and there are finding minimum and maximum. Okay, if we just know a handful of things, we can answer all those questions pretty easily. Okay, so the first is just knowing that these two equations exist and what each of the letters do. Okay, so for each equation, A will tell you what direction the graph opens. If A is positive, it opens up. If A is negative, it opens down. Okay, in the standard form, we can get the zeros of the graph, or where it crosses the x-axis, by plugging it into the quadratic formula. And from vertex form, we can pull out the vertex, which is h and k. We can also factor. Again, this is a skill that we've practiced before, but it's also always helpful to practice a little bit more. And then that can go into several different questions regarding simplifying fractions. And really, that's about it for quadratics. If you get those things, you should be able to do really well on each of the questions on the test. Okay, so that is all I have for you, and thank you for watching.